I farm 1,240 acres, well tiled. I'm a tile person. Yeah, I believe in drainage.
You can see the water down, starting to seep up through the soil down there, the clay substructure. That clay holds nice moisture, but once we get the excess moisture drained out of that, so the roots can permeate in that, this will be an excellent field.
Minnesota is a prime beneficiary of agricultural drainage. So is north central Iowa. We have very tight, heavy clay soils that are only farmable if they have adequate drainage.
I would not be surprised when this is completely done here if the yields would not jump probably about 40% on this field. And in economic terms to farmers, that's a heck of a boost in his income. It might make the difference between him surviving in business and not surviving.
There are several different phases of drainage. The first phase is the conversion of natural landscapes, lands which formerly had a prairie pothole landscape dominated by grasses and wetlands, through drainage, which is stream channelization, surface ditching, and subsurface tile drainage. That landscape was altered into what we have today. Highly productive agricultural landscape which generates annually several $1 billion of revenues for the state of Minnesota.
The tile systems in Minnesota were put in at least 100 years ago. The lower ends of the watersheds, the wetter areas, were most frequently tiled. The upper ends of the watershed also needed tile under certain circumstances.
If we have quite a bit of subsurface drainage installed in areas which don't have the proper design capacity for the outlet, you can get back pressure in a tile system. The water can actually flow back up through surface tile intakes and flood pothole areas at the lower end of these watersheds.
Farms up above are putting more tile on, and the farms down below are putting more tile on. This ditch was put in 1915, all put in by hand. This ditch has had a lot of problems is because you got resistance. The main right here happens to have a 10th grade for a mile, and the tile is laid in peat. That creates a blowout.
This is a blowout where there's water coming up from the ground, from the broken tile, that runs above ground down to a ravine, which ends up in Rice Lake then.
When the water goes back in, that's when it takes the dirt with it. I would imagine the Rice Lake over there, I'll bet there's tons of dirt from this tile went into that. I used to farm the land north of here, quite a bit of it, on the top end of this ditch. And at one time I repaired a blowout up there, and I took 7 tandem loads of dirt and hauled in there and leveled it all, packed it. We had a good rain, and 7 loads of dirt went down this tile.
When they were put in 60, 70, 80 years ago, were never meant to handle all this tile drainage systems that we put into them. They were just meant to drain a pothole here and there and to take those things out so a guy could either farm them or pasture them. But now we've gotten into modern day agriculture where if you can drain your land adequately, that's probably the best way to improve your profit and your yields.
This parcel of land is 78 acres. When the water's like it is, you'll lose about 28 to 30 acres. This, of course, is the pain in my side. Like the last 7 years, I haven't had a crop out of here. Back in the 70s, well, I'd probably lose a crop once in every 5 years.
Tile systems basically are designed for a 40-year life, and there's a lot of areas where they need to be either replaced or repaired. Unfortunately, some of those systems are going to be too costly to replace because the size and diameter of tile would be just economically unsound. And so there's a tendency to take those out and make them into open ditches. But it doesn't solve the long-term problem as you continually add more capacity or you have more drainage brought into the watershed. You're still going to overtax the whole system.
What we seem to be doing is moving water from one farm to another, and the further down the system we get, it just compounds the problem. The downstream landowners are really starting to say, hey, what's going on here? Why are we moving all this water down here and the outlet is inadequate to handle it, so it backs up?
Well, you see, what you're talking about is cost. Now, this is a county tile, so we all get assessed. on this county tile. If we're spending $4,000 or $5,000 a year repairing this every year and we're still drowning out.
To repair this section, this third to a half mile, is about $4,000. The cost of the entire project, which is about 1.5 miles, 1.25 miles, is between $18,000 and $20,000.
Part of my job as a county commissioner is to maintain these drainage systems out here in agriculture to their original engineered intent. As I look at the money that I have to spend, and it's tax dollars levied on these farmers to repair these systems, and it really doesn't improve the drainage at all. Got to thinking, how can we really address agricultural drainage and improve it? But you'll still look at the environmental side of this whole discussion on water quality. I don't think it's business as usual anymore. I have a committee that's urban and rural water management on the Minnesota River Basin, and we have monthly meetings trying to address the environmental concerns about not only agricultural drainage, the phosphorus and nitrates, but also the urban runoff and the urban discharge plants that are putting phosphorus into the waters.
You'll see this area.
What we really haven't addressed through the years is the downstream impact.
If you apply a lot of fertilizer in excess of what is reasonable for crop uptake, you lose quite high amounts of nitrogen through tile drain systems in wet years.
We've talked about the nitrate levels of 10 parts per million as the EPA health advisory limits. Under most circumstances, our tile lines deliver greater than 10 parts per million to the ditches and to the rivers and streams, and also a contributory factor in the Mississippi River.
You know, everybody is in a production-orientated society. We want to produce at maximum, but we also have to be cognizant of our neighbors. And when I say neighbors, I'm not just talking about your next door neighbor. I'm talking about your neighbor might be in the next state or even all the way down to the Gulf of Mexico, because what we do on our land impacts everybody else.
Now, in the Gulf of Mexico, they have a problem which is called low oxygen or hypoxia. And the zone of low oxygen in the Gulf of Mexico is over 7,000 square miles in size. It's having a serious impact on fisheries and tourism in the Gulf of Mexico. And it's thought that this hypoxia problem is caused by nitrogen, phosphorus, and silicon that's flowing to the Gulf of Mexico from the Mississippi River.
Our little day-to-day activities, even though we don't think we're really doing much to the environment out here, once you start putting them all together, they really have an impact on the big picture, I think.
From a long-term ecological aspect, and we're talking ecology of the entire watershed from farms on down to the Gulf, we have to address some of these problems. And we have to have some ownership of some of the nitrates that ends up in the Gulf from central Minnesota.
We've drained and drained and drained, and now let's farm the best and try and do something with the rest.
What we need to do is go back up on the watershed and try to reduce downstream impacts all the way along.
About 7 years ago, we acquired a 200-acre undrained site, a unique opportunity that had 30 acres of wetland in class 1, 2, 3, and 4.
We're installing a agricultural drainage research facility.
Then you can hit it on automatic.
We're installing tile, both with tile plows and trenching machines.
It is very fertile farmland, produces excellent crops, but it does need internal drainage. We have targeted 9 separate experiments to look at how much drainage, how close the tile lines need to be, how deep they need to be.
Water movement, both subsurface and on land. We also want to do some checking the nutrient levels in the drainage water to try to move it through wetlands and use wetlands as part of the overall scheme of things in the landscape. We're incorporating into our system some water retention basins. We're using existing wetlands that will hold water for extended periods of time. We're standing here in a grass waterway that's bringing water down from the watershed behind us. It's approximately 60 acres of water that flows down this area towards the ditch. And what we're doing is we're building a basin here to hold and collect this water and slowly release it into the ditch system so that we can reduce downstream impacts of flooding or high water levels to the farmers and the cities below this area. We could probably hold back all the water off of this farm for approximately 72 hours after heavy rainfall. If we can move the time element by just 3 or 4 days, then the system will work just fine. If we all would do that, we would have a lot less flooding or at least high water movement going down these ditch systems.
This unique partnership in agricultural drainage at the Southern Research and Outreach Center was only made possible with the very significant contributions of the Minnesota Land Improvement Contractors Association, helping not only us, but the entire agricultural industry better understand agricultural drainage, water quality issues, wetland issues, and we're doing this together.
You know, farmers are some of the original conservationists in this country. We're just like everybody else. We want clean water, clean soils, and a better environment. And some of the things that we're going to do here, hopefully, will produce those.
This kind of information and the partnership and the bringing together of agricultural interests to collectively address a problem is really needed.
And I really think our goals are all the same. Can we enhance our drainage systems for agriculture, but yet address the environmental issues? I think that's where we are with this great debate on water quality and water quantity.
Drainage has been essentially paid for through a benefits assessment process. As we start to hear more and more about creative new designs for drainage systems, oftentimes public resources come into play through some of the agencies who are here today.
We need to assess and determine how we pond water, how we take land out of production, and who should bear the entire cost for that. Certainly, in my mind, not the individual farmer, or probably even the county, or maybe not the state. I think it should be a federal component.
When you start reestablishing wetlands or retention basins, and you know that from Hennepin County, they don't come cheap. If we, in fact, are going to increase water quality for people downstream, shouldn't those people be liable for some of the cost?
That's the bottom line of this whole thing. The farmer has got to be paid good comparable money for that basin that we're going to pond the water in. He's going to raise water and ducks instead of corn and soybeans in that land.
The leadership needs to come from a local basis or a collaboration of local entities in conjunction with support from state and federal.
When you look at the 11 million acres and I think 12 major watersheds in the Minnesota River Basin, how are we going to enhance that river?
We could just come up with some way to design the kind of systems that, you know, Ralph is putting in Faribault County.
This little project I got on JD10 that's 3,000 acres looks like a mosquito attacking an elephant, but in reality that's where we got to start, is right up where the water starts moving. We started looking at upland water retention. That's turning the whole thought process around as to drain, drain, drain. Let's start looking at what I'd call undraining some. You have to find the right kind of a basin and the right kind of upland grade in the system to make this function. And we found one in Prescott Township. JD10 was obvious. It's all tiled. There's no drainage ditch there. And as we worked through this, it became evident that there will be far more benefits than just trying to make these old systems live longer and make them work better. If you take a basin out here in agriculture and look at ponding the water there, you can get some water quality enhancement as we pond the water and manage the water level. We can get some wildlife spin-off. We can address the downstream impact with that. By taking some of that load off in that old tile system, it will actually bring up the efficiency on it.
In this situation here, where we're going to dike it and control the flow, that's got to be all ponded real good so you can control the flow.
That's part of the key to this thing, is local control. Getting flexibility into some of the rules and regulations that we work with, and start flexing the program so the local level can have a little more input and say into it.
From my side of the table, it's, I mean, I'm not even considering planting it because the risk is too high. So their program should work.
If you can show a farmer in agriculture how something will benefit them, I mean, that's step number one, because the landowner up to now is the key of how we're going to make this work. They have to be receptive to it.
In a farmer's eyes, They might look at it as sacrificing this tillable land, but we're really not. Not if we're improving drainage on thousands of other acres in this ditch system.
What I could see is maybe
the other unique thing about this project is that it brings the people interested in wildlife, the environmentalists that are interested in water quality, and the farmers together.
Landowners starting to come in and say, hey, I got this old basin, can we do something about it? It's up to individual landowners to come forward, and we do have other landowners in Faribault County that really are starting to look at the benefits of returning some of these old basins either into dry lakes or water retention or even wetlands.
My motivation is to be able to come out here with my dad, my kids, and hopefully my grandchildren someday.
You see any?
We can hear pheasants cackle, we can hear ducks, we can hear geese.
Well, I hope so.
There'll be enough cover to hold deer.
We need something like this.
My dad always told me that no matter what you do, how simple it is, if you can't leave it as good or better than when you started with it, don't do it. What are we going to leave to future generations? I think it's just that simple. And if we don't start addressing these things now, we've gone so long in one direction, moving water. We need to look at alternatives to that.
This was a good start. It was an awfully good start to bring some groups together to begin to build some trust. We're all together in this whole thing, so education is key, and if we can talk, we're going to educate each other.
Elder Leopold, probably one of the greatest naturalists, and what he said was the practice we now call conservation, or to a large extent local alleviation of biotic pain. They're necessary, but they must not be confused with cures. The art of land doctoring is being practiced with vigor, but the science of land health is yet to be born. And health is the capacity of the land and the water to self-renew. Thank you.